Today we're going to talk about alkali metals. Alkali metals are highly reactive metals found in group 1 of the periodic table. However, this excludes hydrogen because hydrogen is a non-metal and therefore cannot be an alkali metal. The elements that are classified as alkali metals and are located in group 1 are lithium, sodium, potassium, rubidium, cesium, and francium. Alkali metals are the most reactive group of elements on the periodic table. They are extremely reactive because their outer shell only has one electron. This means that during a reaction, alkali metals lose that outer electron to another element during the process of ionic bonding. Furthermore, alkali metals react at a standard pressure and temperature, which also increases the reactivity. Because alkali metals are from the same group, they all have similar characteristics. For example, they're shiny, soft, release heat and light during reactions, react violently with halogens, acids, and water, and they do not occur freely in nature. Moving down group 1 of the periodic table, there is a decrease in the melting point, a decrease in the electronegativity, decrease in the boiling point, an increase in the reactivity, and an increase in the atomic number of the element. The following are examples of alkali metal reactions. The first reaction is an oxidation reaction. This is when oxygen reacts with an alkali metal and produces an oxide metal. Furthermore, this type of reaction changes the appearance and reactivity of the alkali metal. As shown in the picture in the lower right corner of the screen, you can see that there is a black layer formed around the outside of the metal, which was produced during the oxidation reaction. This layer will decrease the reactivity of the element. The next reaction occurs when the oxidized alkali metal reacts with water to produce a hydroxide compound, which is more commonly known as a base. For example, sodium hydroxide could be produced during this reaction. In addition, the hydroxides produced dissociate in water. For this next reaction to occur, a halogen is exposed to an alkali metal to produce an ionic salt. For example, sodium chloride, which is better known as table salt. In addition, most salts that are produced can be dissolved in water. In this reaction, pure alkali metal reacts with water to produce hydroxide compound and hydrogen gas. As the hydrogen is being released during the reaction, it allows the metal to ignite and release sparks, as shown in the photo in the bottom right corner. This video is going to demonstrate some alkali metal reactions.
Whether you've left school or you're still at school, you can appreciate the sheer fun and mayhem that chemistry can be. There's so much to it. Bunsen burners, mixing chemicals. Very nice. Now, you may have been allowed to mix very small amounts of lithium with water. You may, if with a responsible adult, have mixed H2O with sodium. And you may, under very strict scientific control, have witnessed potassium mixed with water. But the odds are, if you have, it will only ever have been on one of those rubbish science videos. There you go, make a present. Oh, thank you very much. These next two are the dog's nuts of the periodic table. They are, if you like, the king and queen of alkali metals. Mix these babies with water, stand well back, and watch the mayhem. And that's just what we're going to do. Mr. Tickle, bring on the rubidium.
Here it is.
Is that it?
Well, it might not look like much, Richard, but it's a highly reactive metal. It's sealed in this glass tube under argon atmosphere conditions, just for safety.
Right, so what's going to happen when you drop that in the water?
Well, imagine, if you will, letting off a hand grenade in a bathtub.
Righto, I'm off. Have that.
Okay.
Good luck. Okay, Tickle. Drop the rubidium in the water.
Stand back, everybody, this one's going to be bad!
2 grams of rubidium will only react when our specially designed vial dissolves in the water, which gives John a few crucial seconds to get into our safety zone.
Yes!
Wow.
That is more like it. Only on Brainiac do you get that kind of science. But I believe we can go one better. There is one more alkali metal we can legally use.
Yes, Richard, cesium, the emperor of alkali metals, particularly nasty, could go off at any time.
And that's it.
Oh, yes.
Brilliant. I like it already. Now, what's that going to do when it hits the water?
Imagine a depth charge in a bathtub.
Fair enough, mate. I'll leave it to you. Good luck.
Thank you.
Okay, John. Go for it.
Warning, 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 extreme danger, clear the area.
As our cesium sinks in the water, the rapid generation of hydrogen gas should produce quite an explosion.
And it does. Magnificent. And I think that concludes today's experiment. There is, I should say, one more, even more reactive metal, francium. But for some reason they wouldn't let us have any of that. But still, there you go. Today's lesson.
Never mixed alkali metals with water.
Please complete the exit slip by either using the QR code or the link below. Thank you, and enjoy the rest of your day.